So we will be starting with angular velocity. Now, pre-requirement for angular velocity discussion is time period, frequency, and yeah, that's it. Okay, what is time period? Quite simple. What do you observe with this? What and all will you observe? What and all are you able to observe actually? That it's moving with a constant speed that we know of. That direction is changing throughout. That's also correct. It's circular, so the distance from a particular point is fixed. It's kind of making me dizzy. Not exactly, but still. Let's pause it. All right. Yeah. So what and all can we see? One more aspect that we can talk about is, right? What is the difference now? Difference between that situation and this situation. Now what is the difference? The speed is increasing, is it not? The speed is increasing. The number of rotation that it's able to cover is increasing. And the time that it takes to cover one round is reduced or more? Did it reduce the time taken for it to go one round? Is it reducing or is it? Okay, I can't. Yeah. So is it did it reduce or increase? It reduced, right? So time period has to do with that. Time period is the time taken for one complete rotation. That's it. As simple as that. If I have an object moving in circular path, if it goes round and comes back to this and it takes 4 seconds, then my time period is 4 seconds. I'll give you guys an example. So we're talking about time period. So if I have, this is the path, okay. And we have an object over here. And it goes in this manner. And if it takes 4 seconds to come back, right? If object takes 4 seconds to come back to any position, actually since it's uniform, so if you take up any position, it will take 4 seconds to come back to a point, right, on the path. I'm not going to write all the details. Then its time period is set to be, then its time period is set to be 4 seconds. Okay, so that's that. Then frequency. Frequency, have you heard of the word frequency? Stop using your phone so frequently. Stop, irritating someone that frequently, or what else? The frequency of test is so much. What does frequency mean? Frequency is how often are things repeating. Frequency of an object in circular motion describes the number of revolution it completes in a given unit time. Okay, I'll go back to that. I have few more things. Time period is represented with, let me actually take a second. I'm trying something. Okay, it's not working out. Okay, guys, I'll just tell it. Time period is represented with T. And the unit of time period will be seconds. Okay, so I'll try to write it here itself, I guess. So the representation is capital T. And the SI unit is, it's common sense. Anything to do with time is seconds, SI unit. Then frequency. Okay, frequency should do with this. Let me, I have the word frequency. Can you see that? So let me reduce it to 1. Resume. Yeah. So frequency, can you see that? So every 1 second it's over here. Okay. Let me reset everything. So frequency is 1, time period is 1. What does it mean? Every 1 second, 1 round is completed. So if I increase the frequency to 2, can you see that? Within 1 second, there are 2 rounds that it's completing. So frequency has to do with how often will the ball come back to a particular point within 1 second. Time period has to do with within 1 second, how many rounds is the object going round. Time period has to do with what time will it take to complete 1 round. Frequency has to do with how many rounds does it go within 1 second. Did you guys get it? So if an object takes 4 seconds to come back to a point, then the time period is said to be 4 seconds. When it comes to frequency, so this is represented with F is what we generally hear. I forgot. Let me check that. So let me come back to that. SI unit is Hertz. It's named after a person, so we have H as capital. Right? All this basic should be learned in your first chapter, how to write units. Now, frequency has to do with if an object completes 5 rounds in 1 second, this is important, then frequency is set to be 5 Hertz. That's it. Okay, so here my frequency was, where is it? 2. So if you guys observe carefully, I know it's not easy. So it's going, every second it's going 2 rounds. If I increase it to 2.5, it's every second it's going 2.5 times. 2.5 rounds basically. If I increase it to 3, right? And so on and so forth. Okay guys, so that is your frequency. Then what else? Symbol I have to tell you guys, denoted by. Then let me finish that up. Let me finish this. Guys, it's represented with F in few of the places. I checked actually. It's represented with F, if not gamma. So it's left to you guys. I mean, left to the book that you guys are using. So if your teacher asks you guys to use a particular symbol, you just use that. So these are the 2 possibilities. And by the way, this is gamma. It's a Greek alphabet, GAMMA, gamma. Okay. It's written something like this. I generally write like this. So if you guys see this, I'm writing gamma, by the way. Okay guys, time period. Time period is to do with, is it still rotating? No, thank God. Kind of making me dizzy. Time period is to do with how much time it will take for 1 round. That's it. Simple, straightforward. Frequency has to do with how many rounds or how many rounds does it go within 1 second. They have a relationship between them. Actually, all this you guys should be knowing by now. Time period and frequency. We're looking at the relationship between time period and frequency. It's like this. If time period is frequency, okay. So if time period is 10 seconds, that is for 1 complete round, it takes 10 seconds. So frequency will be 1 by 10 Hertz. Why is that? If you think about it, it's quite simple. If I complete 1/10 of a round in 1 second, within how many seconds will I complete 1 round? 10 seconds. Or I'll put it in this way. If I go 4 rounds in 1 second, within what time should I complete 1 round to have this? 0.25 seconds. Is it not? If I go within 0.25, right, I start and come back over here. So it took 0.25 seconds. And I keep doing this. This is 1, 2, 3, and 4. If I keep doing this, what is the total time? 1 second. How many rounds? Not writing the entire language. 4 rounds. So what is your frequency? 4. What is the time period? 0.25. So time period and frequency have a inverse relationship. So frequency you can find it by dividing the time period, and time period you can find it by dividing the frequency. As simple as that. Okay, guys. So these are all the fundamentals. These are all things that you need to know. Now we can go to angular velocity. So why do we need angular velocity? Why not stick to velocity itself? That's the first thing that we'll understand. When an object rotates, different parts of the object are moving at different speed. Okay, let me explain this way. Oh, I don't have space over there. See, if I have a disk, or let me just consider even just 2 points, honestly. Right, 2 points are having the same center, so they are concentric circles. Okay, we're looking at the need of, I should have done it niche. The need of angular velocity. Why not use velocity is what I am trying to explain. Okay, say I have a point over here, and say along the same line I have one more point, right? Or let me not do it over there. I have one point over here, same line, one more point, right? And now we have a line connecting them. Okay, so if I happen to go one round, in 1 second, I'll keep it simple. So it is able to go one round in 1 second. 1 second, one round. And the same thing happens at the other end also. With him also. So he also goes in 1 second, one round. Now the question is, did they travel the same distance? Question is, did they travel the same distance? Yes or no? Simple question. Again, not displacement, distance. Answer is clearly no. Why? Because the radius is different. Is it not? I'll show you guys here itself. Okay, let me kind of reset everything. Oh, this does not reset. I'll make it very slow, 0.25. Right? Now, I'll just increase the radius. Look at the change in speed, okay? Look at the change in speed. Is there any change in speed actually? Right? It has to travel faster for it to complete one round within this frequency. So basically this will take 4 seconds to complete one round. You can count it actually. Let me reset. You can see the time. And it's almost 4. Can you see that? Exactly at 4 it reached over there. Now at 8 it will reach my, or let me do it over here. It will be here around 14 seconds. Can you see that? 14. Next will be plus 4, that is 18. Can you see that? 18? Yes, right? Are you able to see that? So I'm just adding 4. And that's why the time period is 4 seconds. It's written over here and the frequency is 0.25. But if I reduce the speed, reduce the radius, what happens? It slows down. That's why we can't use linear aspect in circular motion. Why does this happen is, example is a disk, a physical disk, if I have a disk like this, or can shade it also. Point is, if I have a disk like this is one single piece, a donut, for example, or your eraser, or your what else? Chapati, if you guys eat in the center and everything is left out, if you eat the paratha by chance in the center, I know you guys will not do that. But point is, if you eat in the center, this is one physical thing. If I rotate it, or your basketball, okay? Physically, the basketball is one single thing. But the distance at which each radius is, that will be different, So if you have something inside the basketball and everything is fixed, the rate at which something is rotating, that's different. Forget about that. Actually, wheel. Why am I even complicating it? If I take a wheel, the outer rim will be running at a different speed compared to inner rim. But what is fixed? Angular velocity. The angle being covered every second, that will be fixed. Is it not? Because every part has to move with that angle. If not, things will not work out. Right? So when an object rotates, different parts of the object are moving at different speed. So to describe this spinning motion that considers both the speed and the direction of rotation, we make use of angular velocity. So angular velocity is nothing but how much angle is covered in a second. Okay, there is a parallel to your linear motion and angular stuff. So angle has to do with how much angular velocity has to do with how much angle is covered per second. So let me show so now we are comparing. And angular. So linear velocity has to do with your displacement, by time, right? While your angular velocity has to do with angle by time. That's it. Okay, so we end of it, we'll relate this to, but yeah, you will see that same pattern everywhere. When you go to all this, angular acceleration, centripetal time, no, okay, angular speed and angular acceleration. Those are the two things that we're dealing with now. So all of those places we'll see that. So as a definition, the time rate of change of angular displacement of a particle is called its angular velocity. It is denoted with omega. So angular velocity is denoted with omega, right? So then we have SI unit. I think we have SI unit. So we have unit and dimensional formula. So what would be the SI unit? It would be radian per second. So next we have the dimensional formula. Of omega. I'll start using omega itself. So dimensional formula of omega is equal to dimensional formula of theta by dimensional formula of t, which is 1 by capital T, and this is nothing but your t minus 1, or the standard form m0 L0 t minus 1. Okay, so that would be your dimensional formula. What else do we need to know? Yeah, again, I'll just revise. So to understand angular velocity, we need to know time period and frequency. Time period has to do with within how much time will an object rotate. Okay, so this I have to pause actually. How much time will it take for it to complete one round? That's time period. Frequency has to do with within 1 second how many rounds are being completed. Sometimes it need not be, complete as in a proper whole number. All of these numbers can be anything, any decimal, anything. So it can be any weird number. Like here, frequency can be, you can see that it's 0.25. That is 1/4 of the round is completed within 1 second. That's what it means. Then what else? And now we are looking at angular velocity. So we understand that why we need it, because when we look at objects rotating, the linear speed will be different for every point. It's very complex. If the radius is not fixed, the linear speed will be changing. And if that is changing, then it's really tough to even have a conversation about it. But with angular velocity and stuff like that, we'll be able to tell that it's the same angular velocity. So that's done and done. All these points have the same angular velocity can be told, and our conversation is done. Angular velocity is denoted with omega. SI unit is radian per second. So angle is measured in radians per second. Dimensionally, radian has nothing. And so this is 1 and this is T, and that is your dimensional formula. Now we are moving on to average angular velocity. It's the same thing, guys. It's no different. Right? How we looked at average linear velocity, the same thing. Nothing fancy over here. So same symbol, omega and a bar. Then we have what? Change in, what is the numerator? Theta angle divided by change in time. That's it. Done. Is it complicated? No, right? Very simple. Next is, what do we have? Next case is instantaneous. So actually, let me copy this heading. There's some uniformity. There will be some uniformity. Now, for instantaneous, what will happen? What will happen? You guys know this? Yes. Limit delta theta tends to 0. Is that right? No, delta t will tend to 0. As in when the time is reducing, what is happening to the angle? How fast things are happening? That is your instantaneous angular velocity. Done. Okay, I think we don't have definition in all of that. So that's the funda. Okay, guys. So please copy this. The corresponding write-up is not that. Yeah. There's a circle over here. Okay. So this is your frequency. And this is the write-up I have, small write-up. And one more math we did at that. Where is that? That is helpful. Wait, I had the math. Oh yeah, this one. Please write this. Okay. Then we'll move on to angular velocity. I think that for that a brief write-up is over here. Why we need it. The need of angular velocity. When I tell they, I'm talking about A and B. Then you guys talk about the basic idea, definition, and then we have comparing linear. Wait, what are we looking at? Denoting and stuff. Yeah. And the math.